homework assignment.
Give me a second, please. I want to read the homework.
Okay.
It's easier when I read. So your homework 1, part 1, I believe, right?
Mm-hmm.
And you're saying problem number 4.
Yeah, specifically 4B.
Oh, you're so far ahead of the class.
I'm trying.
That's okay. It's good. It will give you some extra free time in the future.
Yeah.
So
I was just confused.
Okay, go ahead, ask a question.
Because I keep getting 0.4 meters per second squared for the acceleration, and it keeps telling me it's wrong.
Yes, it is wrong. Because it's 0.8.
It's 0.3?
0.8, you see?
0.8.
Right.
Okay.
Well, now I know this problem, so I can tell you up front the best strategy to solve it. Because I know that WebAssign offers certain weird way around.
Right.
I don't know why. But if you have taken physics, you should remember that for this particular motion with constant acceleration, there is an equation that tells you how to calculate location if you know time.
Right.
And you know from this picture and from information that you start from rest, so there was no initial velocity 0. And then you know that, for example, I don't know, pick any time right here, when time is equal to 1.5 seconds, your displacement, or you can say your x coordinate, should be equal to 0.9.
Okay.
So if you use that information in your equation, the motion equation,
And okay.
If you use this equation, and if you know these variables, all of them, there's only one unknown left for you. This is what you're looking for, the acceleration. Now, the WebAssign wants you to calculate first 2 different average velocities and then use them for calculating acceleration. So you make a mistake somewhat because it's a very complicated and very not natural way to approach this problem. So this is the best way to do it.
All right.
Because you know all this from pictures, from data, you know all this.
Okay. All right.
All right.
Okay, that makes sense. And then I was also a bit stuck on number 3. Yeah.
All right. So for this one, I wish I could see your picture because you cannot solve this problem without a picture.
Right.
But why? Okay. What's wrong? Something is wrong with my PowerPoint. All right. So if you read carefully what is happening, you have to draw a picture that literally demonstrates what is happening in that situation. So first, you walk 6.44 kilometers due west. So you need to know this: east, west, north, south. This is not a good location. This is your initial location, and you walk in this direction. This is your distance traveled. What's happening next?
You
Where is it?
turn around.
You turn around, so you make a 180 degrees turn.
Hmm.
And then you walk with that average speed east. Well, of course, if you turn around, so you turn around. And the first question is, where do you stop?
Right.
Is it here? Do you go right back, or you walk even further? So let's see if there's information about that. From your starting point to your destination, the magnitude of your average velocity due west.
Right.
So this is the most important piece of information we need to analyze. But for that, you also need to know the definition of the average velocity.
Mhm.
So
Which is your total displacement over time.
absolutely right. So
Okay.
the average velocity, which has a direction, is displacement over time. The displacement also has a direction. And this displacement, we are told, points in a specific direction. So how does it point?
It points west.
So it has to point to the left. This is supposed to be the displacement, total displacement, right?
Mhm.
And what is a displacement? Next question.
That is just how far.
No,
the,
that's
like
not how
the
far.
position, right?
See, now we figured out the problem.
Mhm.
How far? That is not a displacement, that's a distance, and there's a difference.
Okay.
Displacement is an arrow, a vector, that connects the initial point and final. So if you know the displacement points to the left, and you know it begins here, according to the definition, it must end west from the initial location.
Hmm.
So here is your final location. That means this is how much you walked before you stopped here. So not here, not here, not here, well, here.
Hmm.
This is the distance traveled on your way back. And well, this is the distance traveled to the left. And again, distance and displacement are different things.
Right.
For any 2 points, for any pair of points, you can always assign, let's say, initial, final, displacement, distance, time, average velocity, and average speed. This is how many different entities, items, you can assign for any 2 points. And you have 3 pairs of points. Initial, right here. The point of the return, R. And the final, right here. So for each point, you have distance, you have displacement as one, you have certain time that takes to get from here to here. You know that velocity will be equal to displacement over time. You know, average speed would be equal to distance over time. And then for the next part of your trip, from here to here, there's another distance, another displacement, certain time, velocity, speed. That's the second set of variables. And also you have a third set of variables. This is the total displacement, or we could call it S3. And there's also distance related to this, time related to this, and the average velocity related to this, and average speed related to this. That's the third set of variables. But of course, they all are related. For example, if you would spend this many seconds to go to the left, and this many seconds to go to the right, how much time did you spend for the whole trip?
It's the sum of those two.
Yes.
Right.
The first connection. There's another connection. If you look at the picture, something is wrong. I cannot change slides. All right, anyway, if you look at the picture, this is your, I'm going to recreate smaller version
Okay.
of your walk. This is distance traveled to the left. This is distance traveled to the right. And this is the magnitude of your displacement, basically. If you look at this picture, you can figure out another relationship between these variables.
Is that your displacement, the magnitude of your displacement, is the sum of those two? But since the second one is technically negative because we're moving.
Well, the displacement might be negative, but the magnitude of displacement, this distance, is positive.
Right.
So all these numbers here are positive distances. So how would you write a mathematical relationship for these three positive numbers?
It would be that distance one.
Just say letters L1.
Yeah, okay. L1 equals the sum of L2 plus the magnitude. Yeah, that one. It's a bit hard to see. Yeah.
I know. Yeah, I don't know. I have to figure it out. But anyway, this is a second important relationship.
Right.
So you have so many variables and additional relationships, plus these equations for speeds or velocities. And for these equations, you actually have numbers because they're given to you. Well, in my example, you may have different values. That's going to be speed for the motion to the left, speed for the motion to the right. And this is the magnitude of average velocity for the whole trip. So on one hand, you've got a lot of variables. On the other hand, you also know a lot of values.
Right.
So basically, right now, physics is done. You have to throw in all the variables, all the numbers, and you will have to solve several equations. So it's going to be more mathematics than physics. It's a training in solving a system of several equations with several unknowns. And your unknowns are T1, T2, and this distance, L2. I think essentially, eventually, this is what you're looking for.
Okay.
Well, I'm gonna stop
Yeah.
hinting you on this. I want to give you an opportunity, since you're already ahead of the whole class.
Yeah, no, I was not sure, if I should I'll wait a bit, I mean.
No, so the real rule of the thumb is very simple. If I have not done a similar problem in the class, don't start it unless you have seen something similar before in your life.
Okay. All right, well, thank you.
Yeah, well, you're welcome. Thank you.
Yep, well, I'll see you in class tomorrow.
Well, you will see me, I will not see you.
Right.
All right, goodbye.
Take care, bye.